Okay, so in the previous video we actually talked about the unsigned integer, where we only talk about pure positive numbers only, and we only talk about adding, or we didn't talk about minusing or subtracting. Alright, so for the unsigned integer, alright, you have 16 possible values from 0 to 15. Alright, over here there is 8 possible values, over here is 8 possible values. You just count lah, okay, I'll not count for you. But overall 0 to 15 is 16 possible numbers. Alright, for the signed integers it's going to be a little bit different. Alright, so in this case I'll just simply copy this one and I'll just paste it over here and let you see the difference. Okay, so for the signed integer, alright, because you want to sign the integer such that it becomes positive values and a negative form values. Alright, so instead from 0 to 15, alright, it's actually from 0 to 7, or from 0 to or from 0 to negative 8. Alright, so the axis of symmetry is actually over here, okay, where there is 8 values for this and there is 8 values for this. Okay, later on I'll do an example so you'll get a feel of it. Alright, because it's a little bit slightly different, and I got a method to actually help you with knowing the things. Alright, so therefore let's just continue. So you just need to know that compared to this is the unsigned one, this is the signed one. You just need to know that for the unsigned, you can represent your number in terms of 0 to 15. For the unsigned one, it's from 0 to 7 or 0 to negative 8. Alright, so or in other words, you can say that it's from minus 8 to plus 7. These are all 16 values also. Over here is also 16 values. So you are using 4 bits to represent data in a different way. Alright, so you use a 4-bit to represent an unsigned one, which is from 0 to 15, or you can represent in terms of the signed one, which is from 7 to negative 8. Any of this is still 4 bits. Okay, I hope that this is pretty clear. As such, in your Arduino, if you were to code your stuff, please take note that you're going to use unsigned integer or if you use signed integer. Alright, so these are the little stuff that you need to take note of. Or later on, if you go further up with other multiplication and divisions, you also need to specify the integer type. Okay, it can have signed, it can be unsigned, and things like that. So you need to take note of that. So if it's unsigned, which is the one that we talked about it in the previous video, then you just type unsigned lah. Alright, so signed is just type assigned. Alright, and therefore the method of somewhat splitting out your binaries into a positive section and a negative section is called 2's complement, because there is one complement in the positive and one complement in the negative, so to speak. Alright, so therefore there is 2's complement, and therefore whenever you see signed integer or you see 2's complement, this means that you're talking about a binary that can represent positive and negative numbers all along. Okay, so therefore without further ado, let's just start off with a question. Alright, at least get a feel of it. So if happen that is a question, it asks you that signed integer, solve for this thing. It didn't actually specify to you that whether is it plus or is it minus. Alright, just tell you that it's a signed integer. Once you see it's a signed integer type of question, sure you know that you're going to talk about this type of thing. Alright, but because in the question in the exam you are not allowed to access this whole table, they will not give you this thing. What I recommend is that you memorize this thing. I think it's easier for you to write it down in this manner, right? Since I think you know the binary can be represented in this manner. Okay, so you just write it down in this form, or the rest of your stuff you just write as -1, -2, -3. Okay, so you no need to compute this thing anymore. Alright, this thing is like a macam only. Alright, so the next thing I need you to do is that you need to know the symmetry line. So over here, if it's 0, 0, 0, alright, the standard way of representing your this portion to this portion is that if it's 0, 0, 0, 0, alright, if you change 0 to 1, you'll have 1, 1, 1, 1, right? So this 0 will change to 1, this 0 will also change to 1, so all the zeros will change to 1. Alright, so in this case, this is 1, 1, 1, 1, which is -1. Okay, so if it's this case, if it's 0, 0, 0, 1, then you just switch from 0 to 1 also. So I have 1, 1, 1. This 1 over here, I'll change it to 0. Alright, so this is negative 2. Alright, but if you were to compare this thing, if you flip, this is plus 1. If you flip, it actually becomes minus 2. So they're actually not very much the same. Alright, this is plus 1, this is minus 2. But at least it contributes a fair way to help you estimate what exactly is this talking about. Okay, so therefore the first step I would want to tackle is that I want to know what is this 0, 1, 0, 1. 0, 1, 0, 1, if you take a look, is actually plus 5. Okay, so I know that this is 5. What about 1, 0, 1, 1? Alright, 1, 0, 1, 1, okay, is if I were to flip this thing. Okay, I know that this is definitely a negative values already, because do you find any 1, 0, 1, 1 over here? Take a look. Bo, right? Don't have, right? So therefore you know that it is within this section, which is the negative values. So what I can do is actually to switch. Alright, so I have 0, 1, 0, 0. Alright, so over here I switch it to 0, 1, 0, 0. Okay, so what can you see? 0, 1, 0, 0 actually plus 4. Okay, so how many numbers before you reach plus 4? I have 1, 2, 3, 4. Alright, so I require 4 numbers in order to reach this one. Likewise, by symmetry, alright, I also need 4 numbers to reach what I need. 3, 4. So the fifth number, alright, this is 1, 2, 3, 4. The fifth number is actually plus 4, which is our 0, 1, 0, 0, right? If we were to flip this, right? The fifth number is 0, 1, 0, 0. Correct? So now likewise, the fifth number in the negative one is actually negative 5. Alright, so we will straight away know that this is actually negative 5. This 1, 0, 1, 1 is actually a negative 5. Alright, let's just solve this and see whether do we get 0. Okay, so likewise 1 plus 1 is equals to 0. You bring forward 1. Alright, this is the rule from our previous video. Alright, if you haven't watched the previous video, I think I suggest you watch it lah. Okay, watch the previous video when you come back. Alright, the previous video is actually v7e3, sorry. So therefore now this is 1 plus 1, which is 0. You'll bring forward 1. So over here 1 plus 1 is 0. You bring forward 1. Over here 1 plus 1 is 0. You bring forward 1. So this thing over here is 1, 0, 0, 0, 0. Alright, this 1 over here, you may think that it's actually 2 to the power of 4. Yes, it is, but to a certain extent that we only look at 4 bits. Over here, the 4 bits is actually 0, 0, 0, which is 0. You see? So therefore, this thing over here is its own business already, not our business. Alright, so the sign integer is a little bit confusing, but as by practices, you can actually do it quite well. I hopefully. Alright, so I'll just do out another example. At least you get a feel of things. Okay, the first step you do this type of question. I don't know where I stop, but anyway, I'll just start off with what I just write it down first. Is that you need to identify whether is it a signed integer or unsigned. Alright, so it is a signed integer. Alright, you need to know that whether it's a 0, 1, 1, 1, 1, 0, 1, 1, 1, is it within this system, or is this one within here? Okay, so the first step you just need to write is just write down all this stuff. Alright, the next step is to check. So you need to check whether is this or this within the positive numbers. Alright, so therefore if it is a 0, 1, 1, 1, alright, it's a plus 7. Alright, straightforward. If it's a 1, 0, 0, 0, where am I? Alright, over here, do you see any 1, 0, 0, 0? No, right? So straight away you know that this is within the negative system already. Okay, so what can we do? So therefore the third step is to change the 1, 0, 0, 0 to 0, 1, 1, 1. Okay, so if you change to 0, 1, 1, 1, what do you see? Plus 7. Correct? The purpose of this step, you may find it very weird, right? Is that you need to identify its counterparts in the positive. So its counterparts in the positive is actually plus 7. Alright, so therefore by symmetry, alright, with symmetry at this point, alright, there is how many numbers? There are 1 2 3 4 5 6 7. Alright, so same thing, I will have 1 2 3 4 5 6 7. Alright, over here this is the 8th number, which is this one over here. Okay, so by symmetry this value correspond to this one if you were to flip. So if I were to flip 1 0 0 0, I will have 0 1 1 1. If I were to flip 0 1 1 1, I will have 1 0 0 0, which is negative 8. Okay, so therefore it's being shown over here, your 1 0 0, your question. So you need to, so this step 3 purpose is to find which negative value that you want. Alright, because you over here is a little bit hard to do, right? Because you want to memorize everything is tough. But if you do in terms of the positive one, it's easier because you know by definitions throughout your life you already know how to set up the positive one. So once you set up a positive one, the rest is by, so this step 3 is to help you to find which value corresponds to which value that you know. So I hope that you get what I mean. So you have, if you are given 1 0 0 0, first thing you need to switch it to 0 1 1 1, so that you need to find its corresponding counterparts in the positive. So you need to know how many numbers from the symmetry away. So you see that there is seven values before you reach plus 7. So likewise over at the negative side, you also need 7 values before you reach your particular values in the negative zone. And this is the value that you want to know because it's negative 8. Alright, hope that this is pretty clear. So there's this particular step 3 purpose, alright, is to help you find your values over here. You need to know which value are you looking at. Alright, because in the test they will not give you the table. You need to own self find, and therefore it's troublesome, right? So therefore anyway, yeah, so we know that 1 0 0 0 is now negative 8. Alright, so if it's 7 negative 8, you will have equals to negative 1. Alright, so therefore how do we represent this? Let's just add this up and then we see how. Alright, so I have 1 0, I have 1, 1 0, I have 1, 1 0 plus 0, I have 1, 0 plus 1, I have 1. Okay, so if you look at the table, 1 1 1 1 is actually a negative 1. Okay, so this is just because if you have this table, if this table is provided to you, alright, it's pretty simple, just sub in only. Alright, the step 3 over here is simply because if you are in exams, this table is not provided to you. So the step 3 is to help you to find things easier. Alright, and this particular step 3 is a crucial one. So you need to understand how this step 3 works. Alright, after that you will know everything already. If you happen that you understand, you can skip this part now. If you don't understand, I'll highly suggest you continue. Alright, because I'm gonna use this step 3, alright, I'm gonna focus on step 3 to practice how do you find the values that you want. Alright, for example, I have 1 0 1 0. Alright, it is a signed integer. Okay, 1 0 1 0, if you take a look over here, do I have any 1 0 1 0? Don't have, right? So therefore you straight away know that it's in the negative section. So therefore the next step I do is to change the 1 to 0, change your 0 to 1. Alright, change your 1 to 0, change your 0 to 1. So over here, this particular part, this part over here is what you want to find. Alright, you know that it's somewhere over here, but you don't know whether which numbers. Right, because in exams you're not provided by the table, right? So this is what you write it down. The next step is that you write it in terms of this. So 0 1 0 1 is what? 0 1 0 1 is over here, plus 5. Alright. So there is 1 2 3 4 5 6. Alright. So therefore there is 6 steps in order to get 0 1 0 1. So by symmetry, as we keep on saying, I have 1 2 3 4 5 6. So the 6 steps over here would be your 1 0 1 0. Alright, you see? So if I were to go into the table, if you were to just check it out, maybe is it at the bottom? Wait, yeah, so if you were to check it out, your 1 0 1 0 is over here, which is negative 6. Okay, same thing as what I've shown you over here, you see. So therefore, I hope that this is pretty clear. At least you get to know what I'm doing already, because I'm focusing on this particular step. Alright, it's because I want you to have a way or the method to actually solve for this type of questions. Alright, so that if it happen that they didn't provide you the table. Alright, so another example, let's just do another example. For example, I have 1011. Okay, find what is its corresponding numbers. So we know that it's a signed integer, so 1011 is what? Do you see any 1011 over here? Don't have. Okay, so therefore 1011 is somewhere belongs to the negative area. Okay, so what I can do is to flip this again. Alright, so I have 1, I change it to 0, 0 I change it to 1, 1 I change it to 0, and as you notice, yeah, I change it to here. So your purpose is to find 1011. In order to find your 1011, you flip this first. Alright, to find its counterparts in the negative. Alright, so 0100 is where? 0100 is this one. Okay, so how many columns do you need to reach this values? Alright, so I have 1, 2, 3, 4, 5. Okay, so likewise, if I go in the negative direction, I will have 1, 2, 3, 4, 5. This is the fifth value, and therefore this thing over here is your 0100. Alright, and your 1011 is actually your, sorry, I shouldn't have said that. This is 0, yeah, this thing over here is 1011, damn it. Yeah, so your 1011 is actually negative 5. Alright, so straight away you know that this is negative 5, and that's the answer. If you have to check in the table, 1011 is negative 5. Okay, so this is a method to actually help you to define your stuff properly. Right, if you didn't have any table, straight away you just write it down these things as I say, and then you can carry on with this. Alright, but last but not least, I'll just ask you one last question. Signed integer 0011. Okay, what is it? The first step first, I need to find whether do I have any 0011 over here. Then I have this plus 3. So you know that it is equals to plus 3. And that's it. So I assume that you're already pretty pro. So in the next video, I'll do a practice question. Not practice question, but my own practice question. So that at least fully you know what the hell is going on. Alright, so see you in the next video.